one-sided limits have an interesting property to where they always exist, unlike regular double-sided limits. And because of that, certain things can happen that are a little strange. And so I'm going to introduce you all to a technique to help figure out problems that can arise. So the limit as x approaches 4 from the left side of 1 over x minus 4. So what we want to think about here is, if we were to plug 4 in to this equation, we're going to get 1 over 0, right? So, if we were to plug that in, we get 1 over 0, which that's not going to work, right? That's a vertical asymptote of some sort. Well, that doesn't answer the question of what's the limit as x approaches 4 from the left. So what we need to do is think about what happens to this equation when 4 is being approached from the left. So look at the part of the equation, or excuse me, sorry, I keep saying that. Look at the part of the limit that has to do with x. So we have x minus 4. Well, what happens if we would do 4 minus 4? So a number that's smaller than 4, and we take 4 away from it. So it's going to be really close to 0, but our decision here is it positive or negative? That's what you want to decide. So, is it positive? Well, if you take a number smaller than 4 and subtract 4 from it, no, it won't be positive. It should result in a negative number. Now, this is going to be a really small negative number. So the way that we're going to write this is I'm going to call it negative 1 over infinity. Now, you may ask like, well, that's not a number. Well, no, it's not. And so what we're trying to do is show a little technique to help you figure out what this limit's going to be. And it's going to help make sense to you. So, if I were to say, this limit as x approaches 4 from the left of 1 over x minus 4 equals 1 over negative 1 over infinity, I can then simplify that, right? So if you think of the number on the bottom as a fraction, so negative 1 over infinity, I can multiply my numerator, which is 1, by my denominator flipped. So it'd be negative infinity over 1, which just overall makes negative infinity. Now that's the limit. That's what happens to this graph. From the left side of 4, we're actually approaching negative infinity, right? And so if we were to do that from the right side, the limit as x approaches 4 from the right side of 1 over x minus 4, we do the same kind of thought, right? We think to ourselves, well, what happens when I plug a number bigger than 4 in? So a number slightly bigger than 4 minus 4, well, that's going to be a positive, right? This one's positive because it's a little bit bigger. And so it's 1 over infinity for that part. So when I go and set this up and say, well, the limit as x approaches 4 from the right of 1 over x minus 4, that equals 1 over infinity, which can be simplified as 1 times infinity over 1, or just regular old infinity. So this technique allows us to figure out kind of what infinity is going to be. And infinity is happening because we are dividing by 0, roughly. But it's not quite 0. We're approaching it dividing by 0, and as we do that, the denominator, or excuse me, the value of the limit just becomes astronomically high. So the technique again is to try to think about what's happening to the expression when we're approaching a number from one direction or the other. It could result in just a regular number, or it could result in a positive or negative infinity. And then by using 1 over infinity or negative 1 over infinity, we can get analytically to the answer pretty quickly.